Hello everybody, and welcome to the video on the number line and interval notation. Just so you know before we begin, interval notation is something you're going to be using from this point on in this pre-calculus course. It'll be used first semester and second semester, so understanding it earlier is much better. That's why we introduce it during this kind of getting ready for first unit to help you later on in the course. So before we get to interval notation, I want to quickly draw a number line here and remind you that it generally goes from negative infinity to positive infinity. And infinity, again, is a symbol that mathematicians use because we don't quite understand how large numbers can get. So we can't physically touch those numbers. So mathematicians came up with a symbol infinity. And you can absolutely take your paper, turn it vertically and write an 8 and then flip it around if you have trouble drawing infinity signs. But infinity really represents how large and how small the real number system can get. And so above this, what I'm going to do is write that the number line is really the real number system, every possible number that exists. The reason I want to mention this first is you just watched a video on the real number system. The natural numbers, whole numbers, integers, rational and irrational numbers together make up this entire number line. The only thing that's not on this number line are the imaginary numbers. So what if at this point I didn't want to talk just about the real number system? I wanted to talk about a portion of the real number system. And I'm going to write two options, both written in interval notation. So I'm going to write one thing with a parenthesis 4 to infinity. And then in a different color, I'm going to write bracket 4 to infinity. Now these two things have a little bit of a different meaning. What this means is that because there's a parenthesis, the 4 is not included. And a infinity symbol always has a parenthesis because, again, it's something as human beings, we put an infinity symbol because we didn't understand how large the number really is. So because we can't touch the number, we're going to have a parenthesis and not a bracket. However, if we do have a bracket, that means that the number is included. What that means on the number line is this. If I have a 0 as a placeholder and I have a 4 over here, first in purple, what this would look like is you would have an open dot on 4 because it's not included, and then you'd be going towards positive infinity. So your shading would go all the way towards the right in this number line. Versus if you were going to graph what's in red, the 4 is included, so you'd put a closed dot and then shade all the way towards infinity. So the main difference is in the 4, if it's included or not. And you remember this kind of logic from your Algebra 1 days. It has also been seen before that on the number line, instead of the open dot, you could put the parenthesis on the 4 and could put the bracket on this 4. I don't use it as much, however, it is sometimes used in different textbooks. So I thought I'd give that option to you as well. Another thing I want to make sure that you know before we move on is anytime you see a number that is not included, what that really goes with is either a less than or greater than symbol. Versus if you see a bracket on a number, that means you either have less than or equal to or greater than or equal to. How I remember it is if you see the two lines here on the bracket, that goes with these two lines here because, again, the number is included. And in this definition, less than or equal to means that you could actually include the 4. So now let's get to examples that were given to you. So if we look at this first one, what we want to do with x is greater than 3 is this is written in inequality notation. We want to write it in interval notation, and we want to graph it to start. And so what this really means to me, this first one, this means all values that are greater than 3. So something you need to know about interval notation is that I always consider it written left to right, or in other words, smallest number possibility to the largest number possibility. So if this says that you are dealing with all numbers bigger than 3, notice there's no or equal to, so not including 3, you need to start with the 3 somehow because that's the lowest possibility. Because the 3 is not included because of the no equal sign, we'd put a parenthesis. And the highest possibility is all numbers bigger than 3. Well, the symbol we use to represent the biggest number towards the right would be infinity. So my interval notation would be from 3 to infinity. Versus part B. We'll get to the graphs in a little bit. But part B in interval notation, this says we're dealing with all numbers that are less than or equal to -1. So that means this time -1 is the biggest number I'm dealing with. So I would have -1 on the right side, and I would have a bracket because it's actually included this time. Now, if you think about it, if -1 is the largest number, that means it came from the absolute smallest number, which we've classified as negative infinity. Remember that infinities are never something we can touch, so they will always have a parenthesis on them. Part C is saying that the number we're talking about is between -1 and 3. It is included with -1, and it is not included with 3. So if I were to write this in interval notation, my numbers are all between -1 and 3. So I'm going to start with -1, smallest possibility, 3 to the largest possibility. I'm going to put a bracket over -1 because I have an x is greater than or equal to -1, and I'm going to put a parenthesis over 3 because it's just as x is less than 3 and not included. If I transferred this logic to my graphs, and if I saw either one of these situations, here's what it would look like. For all three of them, I'm going to put 0 as a placeholder. For part A, x is greater than 3. I would have an open dot on 3 because it's not included, and it's everything bigger than 3, so I would shade all the way towards positive infinity. Example 2, x is less than or equal to -1. I would go here at -1. Because -1 is included, I would put a closed dot, and we're going less than or equal to -1 towards negative infinity, so my graph would look like this. My third one, part C, is I'm stuck between -1 and 3. So I would have -1 over here, 1, 2, 3 over here. I would have a closed circle on -1 because it's included, open circle on 3, and everything between is a possibility. So I would only shade between those two numbers. And what I want to try to make clear here is that the number 3.00000000001 and so forth, this is included in the set because it's directly next to 3. It is in the interval that works. However, 3 itself does not work. And in here, there is a lot more numbers than -1, 0, 1, 2 that work. 2.9999999 could work. You could have 1/2, 1/4, 1/3. You could have -1/2, 1/4, 1/3. Anything within this interval is true. Now below it asks these same three situations to be described verbally. So if I were to describe part A verbally, I would say this means all real numbers greater than 3, and if you want to be even more clear, you could even write a note not including 3. Part B is all real numbers less than -1. You could say including -1. You could also say all real numbers less than or equal to -1. Part C is the same situation as above, that x is greater than or equal to -1 or less than 3. So you could write that. All real numbers greater than or equal to -1 and less than 3. And if you want, again, if you want to be more clear beyond that, you could say it includes -1, does not include 3. I would say that, honestly, this answer is perfectly fine. All real numbers less than or equal to -1, all real numbers greater than or equal to -1, and less than 3. I think that's completely acceptable, but again, this is if you want to be very clear. This last slide I'd like you to try completely on your own. I would like you to look at this interval. First, try to write an interval notation. Second, draw a number line and graph it. And third, try to verbally describe what's happening. And as you're paused, I'm going to be writing down what I think the answer is, and you can check with me in a few minutes. So please pause now. All right, guys, here's what I got for my final answers in terms of interval notation, going from the inequality notation. I noticed that the 1 was not included, so I put a parenthesis around 1. X has to be between that and 5, so I said 5 was the uppermost possibility with a bracket. On the graph, one thing that I want to just reiterate again is on the graph, make sure if you see no line underneath, you have an open dot. If you do see a line underneath, it's a closed dot. You could also have a parenthesis and a bracket if you'd prefer. In terms of verbal description, here are two possibilities. The first one, a popular one, all real numbers that are greater than 1 and less than or equal to 5. You could also say something like all real numbers between 1 and 5, including 5, but not including 1. Let me just say, let me put the word but in there. So including 5, but not including 1. Something along those lines. Okay, so this interval notation is going to keep coming back in future videos, so please keep practicing. Make sure you know when to use a bracket versus a parenthesis, and make sure to recall that whenever you have an infinity, you are always going to put a parenthesis on it because it's something we can't actually touch. All right, guys, thanks for your attention. I'll see you at the next video.